we reached the last of the inaugural session. We have started our program. So our first resource person and the speaker is our respected Dr. S.S. Mohapatra sir. Hello.
Hello.
Is my voice is audible?
Yes, audible. Okay.
So S.S. Mohapatra sir is a professor of National Institute of Technology. He has awarded so many awards, Brindavan Sahu Memorial Awards for different technical papers, and even if he secured the second best prize paper entitling the Managing Service Quality in Technical Institute, and it's our immense pleasure that Sir has accepted as a resource person. Now we're going to listen Dr. Sivasankar Mohapatra sir. Sir, please welcome sir. Sir, we start our session now.
Thank you, madam. We will start. Good evening, everybody. Am I audible to you?
Yes, sir, voice is audible.
Yes, sir.
So, well, today, actually, I have given two sessions. One is talk on status and prospectus in Indian scenario of industry 4.0, 5.0, and another is the additive manufacturing. Today, I shall give the basics of industry 4.0, 5.0, and most of the things we have our chief guest has given in nutshell. So I shall little bit elaborate and discuss how industry 4.0 and 5.0 are working and what is the difference between these two. Then what are the challenges India is facing right now, and what are the barriers in implementing these systems, and what is the SWOT analysis people have done and how they have identified the issues are. So it will be an interactive session. If you need, you can interact with me at any point of time. Now, as per our chief guest, Mr. Sharma has pointed out, there is a revolution, industrial revolution. When we talk about industrial revolution, these revolutions transform our economies, societies, and lifestyles. That is what we call revolution. So something will change and we feel in the society, and your economy will change and lifestyle will change. Say, these days we are using the mobile phones. Some 20 years back, that mobile phone was not existing. So life of our life has changed. So the technology changes the life. And when the economy, society, and lifestyle changes, we call it a revolution. Rather, it is an industrial revolution. So industrial revolution takes place because of manufacturing, production, and change in the technology. Now, when the revolution will take place, when there is innovation, when the computer was invented, then it started revolution. When internet protocol was designed, then there was a revolution. So all the revolutions has some innovation. So unless there is innovation, new things are not going to happen, and we will not build the new industries, new type of industries, new thought process, new type of lifestyle. So so the revolution bring innovations, and that change the way of life. Basically, if you look at the very primitive ages, old ages, there was a manual labor. Now these days we find some mechanized production, and that is mainly focused on increasing the efficiency in the output, because manual labor with the use of the manual labor, you cannot get the accurate products. So quality will vary from person to person, labor to labor. Efficiency will not be enhanced, and the output will be limited. And so, basic revolution, industrial revolution, started in 18th century when we invented the steam engine by James Watt. Basically, that started or targeted in the mechanization of the textile production in the UK. So that time, Manchester was the largest textile market. So that targeted those period, it targeted textile production. So before that industry came, there were agrarian economy. People were living on farms or farm products. In a manual process, they were doing the farming. So when this textile came, so gradually from agrarian economy to the economy changed to industrial economy. And there is when the industry changed, then from the rural areas, people went to urban areas, and the urbanization and factory-based production system started. The impact, overall impact, is that because of the invention of the steam engine, we enhanced the productivity, but the working condition in the factories were harsh because we have not looked into the uh, condition of the people, because that human part was missing, but definitely we increased the productivity. The next revolution, what we call Industrial Revolution 2, that is late 19th to early 20th century, that has become because of the electricity. And because of the electricity, we could able to do the mass production. So best example of mass production is the Henry Ford's um, assembly lines. That is the mass production. That is the car manufacturing in US. That revolutionized the manufacturing. And when you went for the mass production, from the custom built product to when you go for the mass production, then the cost reduced. The products become affordable in the market. Okay, now during that period when electricity was there, whether the electricity is produced by uh, different methods of technology of producing electricity that is started from coal, water-based water um, water robots, steam turbines, water turbines, steam turbines. Uh, then it went to uh, coal-based power system. All these things that power production that is started. Okay, so then we started railways, telecommunication. So that improved our transportation and the communication. Then steel and chemical industries flourished, leading to economic growth. Then what is the major thing that happened in Industry Revolution 2 is that increased employment, and there is a consumer market that started, and a rise of the global trade from one country to another country. Things were transported and sold, and products were like during that period. The textiles produced in Manchester that is sold in Indian market. So the global market that took place. Then came the Industrial Revolution 3, that is the mid 20th century to present case also. They developed the digital technologies, computers, automation, sensors have been developed, automation, PLC programming started, PLCs were there. So automation started, and there is a rise of electronics, information technology, telecommunication, all these started. So the invention of microprocessor and the internet revolutionized the business processes. So shift from the heavy industries, what we have seen in the industrial revolution 2, whereas there is mass production, heavy industries were there. Now the economy is driven by the knowledge-based economy that started. So the impact is global connectivity, increased productivity, and also the digital divide issues were there. Then came the industrial revolution 4, that is the present and also the future also. That is the integration of the smart technology like artificial intelligence, Internet of Things, robotics, and big data, and we call them smart factories. Okay, then the emergence of the cyber physical systems, autonomous machines. That means machines will have some sensors uh, where the defective items will not be produced. So basically, with the help of the sensors, we make the systems autonomous, make the machines autonomous. It is automation is making the things or the manual work is changed to machine work, but autonomous is rightly doing the things. Okay, any defect, there is no scope for any defective items to be produced. That is, so we have to make autonomous machines. Similarly, you see autonomous mobile robots also, where the automatically it will move in the road. So then there came real-time data processing, cloud computing, predictive analytics that improve the decision making. The impact is that increased automation, improved efficiency, and personalized products and services. But the thing that is the challenges that we are having is the data security. When we are making the so many data and dealing with the personal data, what is the data security? The privacy concern, data may be lost somewhere or it will be taken by somebody. Then the people, they care about the privacy of their data, and people thought about the when there will be artificial intelligence and automation, there will be workforce displacement that may take place. Now that is clearly visible these days because of the development of artificial intelligence. So these days we will talk about G.I.E.T and all that. Uh, AI models that we see and DeepSeek, all these things that we these days see. If you look at the IT industries these days in an Indian perspective, if you look at the IT industries, the recruitment process is very slow. The reason is that most of the things, the Indian engineers, fresh engineers who were joining the IT industries, they were used for making the coding only because the design of the system was given by some outside company, any company in US or UK somewhere. They designed the whole system. Uh, Only the part of the system is given to some IT industry in India. They may not be knowing what is the total system, what is that. They will be given a small system, subsystem of that, and they must be doing the coding and running it. So the routine codes these days can be developed by artificial intelligence. So we don't need that low level people in the IT sector. So those who are skilled or those who have developed their skill over the period, they will survive. And this problem has given a this is an alarming um, and that will affect our economy because from the IT industries we get that is contributes substantially to our GDP. That is going to happen. So, industrial revolution 4, there is because of IT and all that, uh, because of AI particularly, the workforce displacement may be possible. So we have recently seen these days, all these things. Of course, in Industry 5.0, that problem has been sorted out. So if you look at this figure, what we have seen, we have gone through the process from the Industrial Revolution 1, 2, 3, 4. You see, the Industrial Revolution 1 is the introduction of the steam powered machines. In the 2, introduction of the electric power machines. In Revolution 3, through the use of electronics and IT, we, we started Industry 3.0. Now, in Industry 4.0, that is based on cyber physical systems, CPS. In short, it is known as CPS, cyber physical systems. But when we grown to Industry 4.0, level of complexity, system complexity, running the system, understanding the system, the complexity, that has been increased manifold. So unless we will adapt this system gradually, very difficult to realize full potential of industrial 4.0. That is so we have to understand there must be resilience, there must be use adaptability to the changing scenario, and gain the knowledge and how to use the data, how to uh, talk about the IoT, how to build the IT systems, and how the big data. All these things we have to learn. Then, so I'm not going to the technology part because there are many speakers who will be going on the technology part. Uh, Only one technology that I shall be talk to you, um, that is the manufacturing sector, that is the additive manufacturing. But all things has been changed. The system has become very complex. So we have to start with these systems and how it would look. Now come to the basic definition of Industry 4.0. What is it? How? What do we call it Industry 4.0 and where it started? Industry 4.0 denotes real-time, intelligent, and horizontally and vertically networked integration of people, machinery, objects, and ICT system for dynamically managing complex systems. I have shown you that how the complexity increases, complexity enhanced almost 4 times compared to the Industrial Revolution 1. So how to manage this complex system? You use real-time system, intelligent systems, which is a completely network system. Uh, that that is what the definition of Industry 4.0. And this definition is given by Kagerman in 2013. Where this concept has started, basically the concept originally introduced in 2011 at Hanover Industrial Fair in Germany. Okay, and further that has been developed as the high-tech strategy for manufacturing around 2013-14 like that. So basically, the automation was there. Then big data analytics, all these used in the manufacturing, cloud computing, all this has been used in the manufacturing so that we make a complete automated system. Okay, the primary driver lies in the emergence of the advanced technology, including cyber physical system, Internet of the Things, cloud computing. Basically, this cyber physical system is the core technology of Industry 4.0. Now, you understand that suppose these drivers were not there, cyber physical system was not there, Internet of Things were not there, cloud computing were not existing, or that was not invented, then we cannot imagine, we cannot realize the Industry 4.0. It is the integration of all the technologies that has given Industry 4.0. You look at what are the pillars of Industry 4.0. It is Industry 4.0. There is advanced robotics, simulation, artificial intelligence, Internet of Things, cyber security, additive manufacturing, visualization technologies, big data analytics, cloud computing, advanced robotics. All these combined together, integrated together to realize what is Industry 4.0. Now, look at what is this exact meaning of these words that for these technologies, different technologies, what make Industry 4.0 is the integration. So what is these individual technologies? What is their role and what is that? Now, when you talk about the Internet of Things, it encompasses physical device connected via internet. These intelligent devices gather data, interact with their environment, communicate with each other in real time, and initiate action online. Consequently, Internet of Things links people and objects at any time and place using any network or service and connecting with anything or anyone. So, for example, is a simple example of Internet of Things is that we can switch on our AC or switch off our AC while uh, while we were in while driving the car. So through mobile phone we can do that. That is what the Internet of Things. Okay, so there will be sensors connected to the mobile. It works in the network, and that is what we do in the Internet of Things. This is a very simple example. So similarly, in manufacturing, through the Internet of Things, the managers can monitor what is my process, a chemical process is going on, and accordingly he can change the parameters. What is that? So I need to change the pressure or temperature of a furnace, that I can do. So this is what the advancement of Internet things that helped us to visualize, communicate, and through internet and control the systems that has happened these days. Even we can say one another example. People develop helmets having some sensors. So if there is any accident takes place in the road while driving the two-wheelers, then directly the message goes to the hospital. Okay, all these are I mean, due to the advancement of Internet of Things, we can do that, and that's for that we need some. It gathers real-time data. Okay, and communicate quickly and that is through internet. So when you use the internet for the purpose of controlling something or sending some data, gathering or make something use, so we call it Internet of Things. Then another pillar of Industry 4.0 is the visualization technologies. It is also called visualization technologies. It includes augmented reality and virtual reality.
इतने का है, इतना पैसा खर्चा आएगा जो मार्केट में वेलवेटर बैठे हैं ना नक्शा निवेश वो उसका बना देंगे भाई इस पे इतना बनाने में इतना 80% दे सकता है। हेलो बेटा अभी मैं हूँ इटली पहुंच गया बस 2-3 सेक्टर।
So Visualization technologies are augmented reality and virtual reality, which enhance our perception of real world through visual augmentation. The digital tools offer a virtual model of entire production system and their interaction along the supply chain, driving significant changes in how businesses serve customers, train their workforce, design and develop products. So it is just a virtually you can simulate the 3D things and understand what is going on, what is happening, how to control that, and we can visualize the supply chain, our supply chain, how the products are moving, what is the inventory, all these.
अब वो जैसे 15 का मतलब 15 वो अकाउंट वो डाल मतलब 15 वो कर देंगे लिमिट बस जितना उसमें से यूज होता जाएगा
Please mute everyone. It's my request. Please mute.
10 यूज किए
Please mute.
अच्छा जी
Sir, please mute your voice.
उसकी पुस्तक जो भी पाए कहते ले जाओ डाल जाओ पे होती है
Please mute your voice.
आपने 10 लाख
Start.
का 8.5 साल
So then the cloud computing. Cloud computing, nothing is to be told. Everywhere that a cloud is there, where the data will be stored and the computation.
आप ये रिटर्न कैसे करोगे आप आपने 10 लाख रुपए यूज कर लिए मान लो 6 महीने में आप वो क्या लगाएंगे तो ब्याज की कैलकुलेशन होगी वो रिड्यूसिंग बैलेंस वगैरह पर होता है जितना जितने का दे दिया यूज कर लिया उस पे वो इतने कैलकुलेशन तो बड़ी होती है ठीक है मतलब उसकी पेइंग कैसे होगी हर साल 8.5 देने बता ना हर महीने किस्त देने महीने का जितना भी
Please mute everyone.
मैंने यूज कर
Excuse
लिया
me, it's my request.
2-3 महीने यूज कर लिया
Sanjeev
मैंने उसका
Sarma,
जितना
please
मेरा
mute. Dr. Sanjeev Sarma, please mute your voice.
Madam, he is not listening. Please remove him. No, he is disturbing the entire session. Please remove him.
Yes, yes, sir. Yes, sir. Yes, sir.
Okay. And so the little bit disturbance was there, no issue. So cloud computing encompasses data storage, servers, databases, networking, and software that facilitate remote access to information through a virtual environment. It connects various entities as illustrated by 4 primary access models: public models, private, hybrid, and community. So public model means single, private means with a single organization, hybrid means a blend of public and private, and community means shared by multiple organizations that share the common interest and concerns. Now, data is to be stored at the clouds. So people use the cloud storage, for example, those who are having iPhones, they might be knowing what is iCloud. Okay, so iCloud means your data will be not be in the physical system; it will be stored somewhere. Some storage space is there. Or this just provides the storage space. Mostly data storage space is provided by Amazon. Amazon is AWS company. You look at that AWS. So AWS is the main company. Basically, they have the servers. They work. They provide the servers or that storage for cloud computing. So in the mobile, you run your MATLAB. MATLAB you can run it. So there will be a cloud server. Okay, where you can send the data and it will be computed and get to you. You need not to store the data on your mobile. Okay, only we can see the results. It communicates with your storage system. This is what the cloud computing, and that is focused in manufacturing, where data will be stored somewhere, and when you need that, what is the design? So design will be made using your software. What is the design software that you are having? Then the manufacturing codes can be generated, and everything done by the cloud. That will be stored in the cloud. Nowhere in the company it will be stored in device. Then now why it is not stored? The reason is that it needs lot of storage space. So many products that we're producing, so we need space. That is not possible for a company to have the storage space. We pay money for the cloud storage space and get it. Okay. Then the cyber security. Cyber security focuses on safeguarding private information integrated into hardware and software to prevent the misuse of data and devices. So cyber security, a lot of things are even talked about the cyber security people, and there are many methods of how to protect your data, and people are working, all the computer science people are working on cyber security. And if you look at the industry 4.0, it is not the job of the only mechanical engineers. It is a hybrid system or interdisciplinary system where the mechanical engineers, electronics engineers, and the computer engineers, they work together to realize the real life industry 4.0. It is not the only, because mechanical engineers, they mean only the mechanisms and the production system. But what is the cloud computing, cyber security, visualization methods, or Internet of Things? It is only the electronics and the computer science people, they know better than the mechanical engineers. Okay, then another is the simulation and modeling. Simulation and modeling support the verification and validation of the products, processes, and system design and configuration. They also help cut cost, enhance product quality, shorten development time, and reduce both design errors and waste. Then comes the machine learning and artificial intelligence. Artificial intelligence, basically, it means replicating the human intelligence in machines. The way we think, that if you replicate on the machines, say for robots, you make intelligent robots, who make autonomous robots. So if the way human people think how to do that, is the same ideas, if it will be replicated on the machines, then it is called artificial intelligence. So basically, it involves replicating the human intelligence in machines, allowing them to mimic human thought processes and behaviors. Machine learning is a subset of artificial intelligence, embodies the principle that software can learn, adapt from data on its own without direct human input. So what is the machine learning? The software system, we talk about neural network, fuzzy systems, rough systems, all these rough theory, all these theories, what has been coded for identification of the objects, or classification of the objects, or learning the human behavior using the neural networks or other simulation packages, simulations are there. This is what we call machine learning. It is a subset of AI. How the artificial intelligence, how the machine will replicate human intelligence, because if it is trained properly, and training is done by the machine learning process. Then comes the another pillar of Industry 4.0 is the big data analytics. Big data analytics involves gathering extensive complex data sets from multiple sources at various points in time. It includes collecting, storing, distributing, analyzing, and evaluating this data. So big data itself defined as large volume of high velocity complex variable data require advanced techniques and technologies to capture, store, distribute, manage, and analyze. Among its benefits, big data analytics enables predictive maintenance and supports real-time decision making. What is the big data do that. See, large number of data comes to my system. The customer data comes. Now we have to choose at what time. Suppose Alan Soli wants that what type of varieties will be sold in Kolkata market in the month of January or in the month of February. So because they have the customer data, that is a huge data, and there you have to analyze the potential customers of Alan Soli in the region Kolkata. Then you have to identify what is their choices, what style they want. Then you have to order for those amounts and sell them. So you have to make the decision there. So this is what the big data. This is variety data, different data, and you have to analyze them, identify, classify them, and take the decisions. Then comes the additive manufacturing, what you call 3D printing. That is the process of building layer by layer mechanism, and by that the customized parts can be produced and the time can be reduced. So this is what we call additive manufacturing. Basically, part we build in a software, say AutoCAD, CATIA, or Pro-E. Then we send it the additive manufacturing machine. The machine will slice the part, 3D part, and deposit the materials as per requirement, layer by layer. It is completely different from the subtractive machining, where in the lathe machine or milling machine, we subtract the material to give a definite shape to the job. But in additive manufacturing, we layer by layer we go on adding to develop a product. Then another pillar is the advanced robotics, including autonomous and collaborative robots, which interact each other and operate safely alongside humans with the same workplace. So these are the 9 pillars of Industry 4.0, and a lot of things we know, and that has been used. And Industry 4.0 has been, it is not the thought process, or it has been practically realized and working in many industries, in many developed countries. And in Indian industries also, some of the pillars have been used, but complete Industry 4.0 system has not been available, because Indian manufacturing sector is not so advanced even compared to Chinese manufacturing sector. Our contribution to GDP from the manufacturing sector, contribution to GDP is very minimum. So there is a lot of challenge how to improve the manufacturing sector. With the we should not go to the conventional machining processes, conventional machines, because the need of the day is the Industry 4.0 and 5.0. So these are the 9 pillars that make the Industry 4.0. Then came Industrial Revolution 5.0. What is this? Is the emerging trend. It is not completely realized so far. It is focused on human-machine collaboration rather than fully automation. Where we thought that in Industry 4.0, when there will be automation, there will be manpower shortage. That will not be there, but there will be human-machine collaboration, and manpower will be required. Okay, but the nature of job will be changing. I'm giving a small example how the nature of job will be changing. You see, when banks were automated or computerized, people thought we will lose the job. The banking sector will will reduce the men's power. That didn't happen because the nature of the job will change, but the manpower requirement will be there. Okay, it cannot be replaced. So it is emphasizing on human-machine collaboration. Machines will do its machine's job, human being will be taking their own job. But it is the collaboration, human with machine collaboration. And AI and robotics assist humans instead of replacing them. Look at the words. Artificial intelligence and robotics assist humans instead of replacing them. And personalized and customized product and services. What is personalized and customized products and services? Now, since we use data, IoT, big data, then virtual reality, so many things we use. When the customer gives the order to the company, to a car company, that my dashboard should be like this. My seat will be different. So when we talk about the industry 3.4, where automation is there, or industry 2.0, where the where mass production is there, we didn't think about the personalization or customization of the product, because the thing is that my production line that will be affected if I use a personalized product. Okay, so car manufacturing in the assembly line, only 2-3 models of the same product that is to be assembled. Okay, if I ask for the customization, it is very difficult because their production will be affected. But using the industry 4.5, customization has been focused, because the company will be very small, it is completely automated, and customized product will be produced. It can also serve the mass production, but the customized products will not affect the production system. Okay, so, and another important thing is the sustainability and ethical manufacturing. That becomes the priority. Now, greater emphasis on creativity, well-being, and balanced work environment. This is what is the difference from the industry 4.0. I will give in detail what the differences are. We look at the industry 5.0. What are the different there we have seen that 9 components were there, industry, or 9 enablers were there, industry 4.0, cloud computing, advanced robotic simulation. You look at here in industry 5.0, what are the enablers are there? There is a holography, fintech, bionics, AI-based management systems, sustainable agriculture production, cyber physical system, CPS will be always there, green computing, virtual reality, previously virtual reality is there, here also, big data, previously it was there, advanced simulation was there, then this is new waste prevention, smart materials, digital twin, IoT enabled system, IoT is there, it was there, then renewable energy sources. Look at what is the change, that is the holography, renewable energy sources, fintech, bionics, then sustainable agriculture production, then green computing, then waste prevention, and smart materials. These are the different enablers of 5.0. And most of the things are similar to industry 4.0. What are the different that I shall show you? What is that? That is the fintech. That is the fintech is the bringing in digital currencies, digital transaction systems, stocks, and financial investment systems, enabling exchanges in real life. And most of the countries, they're looking for digital currencies these days. Digital transaction is already there, and stock and financial investment system already there in the digital way. But the digital currency is not realized so far. That will come in future. And holography, Holography is generating three-dimensional images. Now, it will using the three-dimensional images of any product, then high precision measurements can be made and make industry resilient. Okay, so holography you have seen in many products when you purchase in the market, you will find a hologram. If you look at the hologram properly, you will see a three-dimensional picture. So holography here helps, not only gives the three-dimensional images, but gives the what is the measurements, precision measurements that we can do with the hologram. Then is the bionics. Bionics is the science of building artificial systems that have characteristics of living systems. It is the technique of imitating nature. It is not about copying nature, but understanding how things work in nature. It helps in making a healthcare industry resilient. What is the bionics? That is, suppose I use the implant, tooth implant, or implant of a cancerous part of the body, and that can be made in the 3D printing. Then we replace it. That will help in the healthcare industries. This is what the bionics. Use the artificial systems that are the characteristic of living systems. But it is the technique of imitating the nature, but it is not copying. It is understanding and making. It is not copying. So that was not existing in Industry 4.0. So Industry 4.0 not only affects the agriculture industry, but also healthcare industry also. Then digital twin. It is the digital representation of an object. It is the often a digital replica of the objects within the physical world, like a reaction propulsion engine, wind farms, or oversized buildings, even cities. All the data we can have. So accordingly, we can take the decision. It directly helps industry to reduce the sample production cost, which helps in creating the industry as resilient. Then the green computing. Green computing is defined as a technique of using computer system in an eco-friendly manner. It is the study of designing, manufacturing, and disposing of computer devices with motive of reducing environmental effects. So we have a lot of emphasis in Industry 5.0, sustainable agriculture production or sustainability, then bionics, that is the healthcare industries, then fintech, digital currencies, then waste prevention, digital twin, and rest others are and renewable energy sources, green. All others are same as the Industry 4.0. It is more sustainable, more human-friendly system. And not only focuses on the automation, but it creates the automation and the human relation in manufacturing process. So, sorry. So, the objective of Industry 5.0 is to establish sustainability and environmentally friendly methods and to enhance existing work and service experiences. It promotes bioeconomy, thus encouraging development in healthcare, medicine and surgery, genetics and bioscience, and incorporating the products of agriculture, forest and animal resources and farm activities. The concept of Industry 5.0 express a optimum utilization of resources as compared to Industry 4.0. However, certain issues exist with any newly introduced concept. Some negative issues of Industry 5.0 include legal and regulatory issues with robots, preference of working robot, psychological issues, human-to-human communication gaps, and employment issues. These are some of the negative effects of Industry 5.0. So there are many advantages and disadvantages are there. So we'll not focus more on disadvantages, but rather we will find what are the differences between Industry 4.0 and 5.0. Industry 4.0 has been thriving in introducing many next generation technologies such as AI, IoT, internet-based services, digitization of banking, finance, transactions, retail, sales, and business, leading to manufacturing has been scaled to a great extent. Services has become more user friendly. This is what the Industry 4.0. However, Industry 4.0 have missed out some of the major aspects of manufacturing, service, and society and the environment. For instance, customization. What I talked about the customization in Industry 5.0, customization was missing. But because of the advanced software and simulation techniques, customization is possible. And the resiliency in development process of Industry 4.0, that was not there. But adoption of concept of 5.0 will lead to better future with resources being better utilized. Renewable energy and green energy will lead to reduce carbon emission level many folds and erase global pressure placed on fossil fuel reserves all over the world. So because these resources can be brought in a new rural scenario and regions with inadequate power setup, they have potential to solve the energy crisis. And the social sustainability, that is more focused on Industry 5.0 compared to Industry 4.0. In fact, in Industry 4.0, these concepts were not the social sustainability was not existing in Industry 4.0. So industries such as agriculture, animal farms, and forestry are still rated as being small scale and rural, even though they contribute a great amount to agro-based economy. It was not there in Industry 4.0, such as India's. So India basically an agro-based economy. So for India, it is quite suitable. For bio-oriented atmosphere, there is a need to upscale this industry as well. Now, there is a high scope of research and development in engineering for medicine and surgery. This field incorporated many innovations to improve healthcare. Engineers and the medical professionals, they will work for resolving many of the medical issues. These fields are on different platforms, but must be focused collectively for moving towards a green, resilient bioeconomy. Finally, these measures are set to effectively introduce into society itself with a vision where human and collaborative robots work together, where highly effective AI manages the reiterative systems, where high quality faculties, products, and assistants are available in a green, healthy, smart environment so as to preserve nature, human values for the generations to come. In this way, human beings are shall progress towards overall sustainability of civilization and planet. Now, impact of Industry 4.0 in India. You look at the government initiatives, always focus on Industry 4.0, Make in India, Digital India, Smart Cities, all these initiatives talk towards Industry 4.0. Growth of AI, IoT, and automation in Indian industry. You have seen this. Expansion of startups and the digital economy, promoting innovation. We have seen this. We have witnessed in last 10 years, all these things. Skill development initiative to adapt to Industry 4.0 technologies. Skill development from the school level itself, talk about the ITIs, talk about the engineering education, talk about medical education, everywhere skill is needed. And we have all-round development of the human beings that should be made, and we learn AI ML is that has become a part of course as per new AICT syllabus. So that is going to develop the skills. What is the challenges that we are having in India? There is infrastructure development that is needed, and infrastructure varies from state to state, city to city, like that. So infrastructure is the major problem in India. Then cyber security. You have seen the hackers, cyber hackers, and they infringe the security and put users into trouble. Cyber security is an issue. So suppose the industry data will be there. If some it will be theft. That is a major issue. So a lot of research is going on this, and all the enforcing agencies, they're finding new ways of protecting our data. Then the upscaling of the workforce, that is the challenges for implementing Industry 4.0. Now, what are these are the impacts and challenges that infrastructure gaps, digital divide between rural and urban areas, that must be reduced. High initial investment required for automation and AI adoption. We should have money for investment. Need for workforce in upskilling and digital literacy programs. We have seen that is going on, and it is still a challenge. Then cyber security risk due to increased data connectivity, balancing automation with employment opportunities to prevent job losses. So these are the challenges for implementing. Industry 5.0, what is the opportunities in India? It is a human-centric manufacturing where AI augments human intelligence. Eco-friendly and sustainable production methods to reduce carbon footprint. Customized products using AI-driven production lines. Stronger industry-academia collaboration for R&D and innovation. Potential for new job roles combining technology with human activity. Now, challenges in India for Industry 5.0 is that ensuring a smooth transition from automation-based Industry 4.0 to human-centric based Industry 5.0. How that transition has taken place? When you talk about the digitization and industry automation, digitization, talk about the Industry 4.0, the world has moved or talked about 5.0. So whether we will implement 4.0 or 5.0, that is the challenge. So the smooth transition from Industry 4.0 to 5.0, that is a challenge now. Now, investing in research and development for human-centric technologies. So the technology will be human-centric, and we should have some innovative way of doing that, and research and is needed for that. Developing ethical AI framework, artificial intelligence framework, and policies for responsible artificial intelligence uses. Artificial intelligence has disadvantage that it can be used for some bad purpose also. So we have to make some way how ethically used and responsible for AI uses. Addressing data privacy, what I have talked just now, addressing data privacy and cyber security challenges, managing workforce transformation to integrate AI with human skills. These are the challenges. So a lot of studies have been made in the last few years where people have used different, mostly multi-criteria decision-making methods. They get the data from the survey analysis, conducted the survey. And these days, WhatsApp and Google form that is has been used for the survey purpose. So digitally you can send the questionnaire to different people or the experts, then get the data, analyze the data using statistical method, or analyze the data using some fuzzy method, or analyze the data using some multi-criteria decision making. So a lot of studies have been done. I'm talking about a particular study where people, where the authors have talked about what are the barriers that is existing for barriers existing for implementation of 4.0 in Indian conditions. The barriers, 18 barriers have been identified. Now, these barriers, it is not complete one. It depends on the on the researcher who has gone through the literature review and found some of the barriers. But if somebody else does it, he may find some more, or the wordings may be different. I'm not saying it is it is just one study I'm showing. So the barriers have been identified is the lack of understanding and knowledge of regarding Industry 4.0 and 5.0 and digital factories. Inadequate digital culture. The inadequate digital culture that is in industries or application in industries. Not that digital culture we are having, we pay by the UPI. We are not talking about that. In industry application, whether the people in the industries, the engineers and the management, they are well versed with the digital culture or mechanization, automation, all these things they know or not, or they are interested for that or not. So, inadequate digital culture. Employee flexibility is required to learn and adapt. Employee flexibility, all timers, they will not learn anymore. So there must be some flexibility to recruit new people who will learn and adapt. Implementation cost. If you go for Industry 4.0 or 5.0, what is the cost? Implementation cost. Virtualization and dynamic integration. Integration of physical system with cyber systems. Lack of proper global standards and reference architecture. This is important. Lack of proper global standards and reference architecture. Now, uniform standards for tools and equipment, systems, languages, networks, that basically uniformity. It talks about the uniformity, uniform of the standards, protocols, what you call protocols in in computer science. So uniform standards for tools and equipment, systems, languages, networks, data services, and reference architecture like design and selection. Quick reconfiguration of manufacturing system, assembly system, inspection and material handling systems. Quickly reconfigure. Real life full data sharing and monitoring among various units, customers, suppliers, logistics, and a few selected data sharing with other industries. Government policies and support, data and information security, privacy protection, clearly defined investment returns and economic benefits of digital investment. This is the point 14.14 is mainly targeting the management because they will invest the money. So whether they are interested, clearly defined investment returns, they want the ROI, return on investment. So whether they are interested to invest or not. Under uncertainty in the interest of Industry 4.0, whether Industry 4.0 will survive or not. So that uncertainty. Several complex legal issues, lack of integration of technology, data quality and big data. Data quality and big data. So even our census data, if you collect some data, it may not be, we cannot rely on the data because a lot of noise is there. Okay, so data quality and big data, all these 18 points or 18 elements to talk about barriers in implementing Industry 4.0 or 5.0. So these are the clear definitions of these barriers. Say, lack of understanding the knowledge, it is clearly defined. Lack of robust empirical research on this new technology. Unaware about new smart devices and technologies. Digitization and homogeneous data industrialists are unsure about its value and implication consequences in their existing manufacturing system act as a barrier to adopt Industry 4.0 technologies. Second one is the inadequate data culture. Digitalization refers to the interconnection of all the manufacturing systems, designs, development, logistics, market market predictions, customer demand, and feedback through wired or wireless network, where data are kept transparent and hassle-free, which is challenging to achieve in existing manufacturing industries and hence act as a barrier to Industry 4.0 technologies. So why these are the barriers? That is clearly mentioned for all these 18 barriers. Survey methodology have been used. Then after that, some fuzzy logic method has been used. Then in Indian scenario, we find that C3 is one of the most important barrier. C3, look at the C3. That is the employee flexibility is required to learn and adapt. Here, as Industry 4.0 is the latest technology and keeps upgrading daily to get robust and is essential based on data analysis, big data connectivity, and information technology applications. The employees need to upgrade their skills quickly to get acquainted and give their inputs efficient IoT solutions. Most employees most employees find upgrading themselves to multi-skilled a challenging task and uncertain about its future implications, which creates disruption and fear of losing jobs. Thus, it acts as a barrier to adopt Industry 4.0 technologies. So, Industry 4.0 is a major hindrance is that the existing industry professionals, they do not want to learn, they do not adapt themselves to the new technology. They are skeptical about the future of this new technology. They find it that it is not beneficial because they may lose their jobs. Because if everything is automated, then there is no need of a human being and worker in this place. So this is most important barrier. Then another important barrier is C6. That is the integration of physical system with cyber systems. Look at the C6. Many complexities are generated to design and integrate the numerous traditional manufacturing systems and components via complex coding and software technologies and interconnect them to cyberspace. This creates barrier in adopting Industry 4.0 technologies in technological and implementation aspect. 6 is the most important barrier. Okay, integration of physical system with the cyber system. Then first, second, and the third most barrier is that C10. You look at C10. C10. Real-time full data sharing and monitoring among various units, customers, suppliers, logistics, and a few selected data sharing with other industries. So the total definition is given here. Real-time full data sharing and monitoring among various units, customers, suppliers, logistics, and a few selected data sharing with other industries is still a novel paradigm. Moreover, the complex paradigm programming and modeling or massive data cluster generate difficulties without accessing the actual data from the system and components. Lack of transparency in system acts as a potential barrier to adopt Industry 4.0 technologies. Okay, this is 10. Then you look at 18. There are others, but these are the most important barriers. Look at the 18. 18. Data quality and big data, what I talked recently, just now. Data quality, data storage, maintenance, and assessing harmonious data without compromising on its quality is challenging, as this data collected from each component, sensors, products, manufacturing system, inspecting equipment, market and sales, and customer feedback generates enormous data. This big data helps the system predict and make a decision from the feedback, requiring high quality data. The high quality data is one of the barriers or one of the important barriers in Indian scenario. This acts as a barrier to adopt Industry 4.0 technologies. So then this these researchers, they have used fuzzy methods and found out multi-criteria decision making method using the fuzzy in a fuzzy environment, and found out the various out of 18 barriers. They found out the most important barriers: C3, C6, C10, C18, C12. All these are the important barriers. So once you identify the barriers, make the policies, make the methods, make the systems, so that these barriers can be overcome and you can find a really good or implementation will be easy. Then in a similar manner, some survey-based methods that has been used. Then here the researchers, they have used SWOT analysis, that is the strength, weakness, opportunities, and threat analysis. Here, the researchers have found out some 10 points of implementing Industry 4.0. First one is the promoting awareness about Industry 4.0 among the employees. Another is the second one is the focus on the development of workforce competency development. 3 is the strengthening Industry 4.0 standards and reference architecture. 4 is the capability development to integrate Industry 4.0 for operational effectiveness. 5th one is the develop and upgrade new business models based on Industry 4.0. 6th one is the top management commitment and leadership support towards Industry 4.0 implementation. 7 is the encourage innovativeness culture for Industry 4.0. 8 is the implementation of adaptive retrofitting in the existing system. 9 is the complete cost benefit analysis of Industry 4.0 technologies. 10 is the government policies to support Industry 4.0. And all these 10 ideas, strategies, what we call strategy 1, strategy 2, all these ideas when have been derived from different references, existing references or the papers. Now, after the SWOT analysis, SWOT means strength, weakness, opportunity, threat analysis. We found that strength and opportunity strategies like ST5 and ST4. ST5 is the develop and upgrade new business models based on Industry 4.0. 4 is the capabilities development to integrate Industry 4.0 for operational efficiency. Now, experts have been taken part in this study. Then, based on the expert advice and these strategies are given, then they have been given what is these strength and opportunity strategies and the weakness and opportunity strategies. This weekend of opportunity studies are S3 and S9. ST3 is strengthening industry 4.0 standards and reference architecture, and 9 is the complete cost benefit analysis of industry 4.0 technologies. Then threat and strength strategies are 1, 7, and 8. 1, 7, and 8. 1 is the promoting awareness, and 7 is the encouraging innovative culture. 8 is the implementation of adaptive retrofitting. And the weakness and threat strategies are 10, 6, 2. 2 is the focus on development of workforce. 6 is the top management commitment, and 10 is the government policies. So these are the weakness threat strategies. So different studies are there. What are the barriers? How to implement implementation strategies? Lot of things have been have been discussed and researched. Research articles are there, books are there, but still in India, it will take time to realize a full-fledged industry 4.0 scenario or industry 5.0 scenario in this in the present time. The major reason is that upskilling the people and understanding what is the understanding the technologies, then integrating the technologies, and develop and investment. So these are the government is promoting. Innovation is taking place gradually. Of course, in a more dynamic way to last 1 decade compared to the last decade, but still we have to go long way for implementing all these technologies and to compete there in Germany or China in the technological front. We have to go a long way. But the things are good that the initiative has been taken place. People are learning the technologies, adopting the technologies, and gradually investment is being made. So definitely it will be realized soon. But at the timing, we have to go a long way. So with this, I can say what is the road ahead for India. Strengthening of STEM, that is the science, technology, engineering, and mathematics. That is the family of it is the umbrella of science, we can call science, technology, engineering, and mathematics. That education to equip students with the industry 4.0 and 5.0 skills. Encouraging startup and innovation hubs to drive industrial transformation. Government policies for sustainability and green energy adoption. Investment in AI, artificial intelligence, robotics, and smart manufacturing. Ensuring digital literacy and inclusive growth to bridge technological gaps. So these are the roads ahead for India. And think of it. I have told you about the barriers. I told you what is our strength, weakness, and threat, and the opportunities. SWOT analysis were made. I have shown you that is not, of course, not my work. I have borrowed from other researchers' work. And what is the road? What are the challenges that we have understood, and what is the road ahead? We are having have understood. So definitely we will definitely improve in this aspect. Thank you very much for your patience and listening to me, bearing me for some.
Sir.
Thank you very much.
Thank you, sir. Any participant, any questions? Participants? Any questions?
Yes, sir. Hello.